binary addition, let's have a look at how to do this. Now, it's not difficult, so relax about it. You know how to do this. It's once you understand the rules of it, you shouldn't have a problem. You just need to take your time while you're doing it. So the first thing we have to do is some of the rules. So we know there are only two binary symbols. In the binary number system, we have a 1 and a 0. That's all there is. So that means that every number that we create in binary is composed of a series of 1s and 0s. Now for this demonstration, I'm going to add the decimal numbers 15 plus 7 together, which make 22 base 10. And over here in the workings, I'm going to add extra workings to explain it, but you don't need to do this once you become familiar with it. So the first thing we have to do is write down what 15 is in binary. And it's actually made up, you can express 15 in 4 bits, and as you know, 4 bits is classed as a nibble. So 1, 1, 1, 1 is the same as 15, and that is so 8 plus 4 plus 2 plus 1 will give you your 15. And now to add to that we want 7, so we need a 4 plus a 2 plus a 1. And let's put the 0 in, just to balance that out. Now to add these together, it's just like the chimney sums that you're used to, but this time you've only got binary digits to express it in. So 1 plus 1, now if we write this over here in the workings, 1 plus 1 equals, now you know equals 2. But the problem is we can't express a 2 with the symbol that we're used to, a 2 symbol, because it doesn't exist. So a 2 in binary is written as 1, 0. The 0 is because there is nothing in the 1's column, and the 1 is because that's the 2's column, so there's 1, 2. So what we need to do is we write into our sum what's in the right hand column, so that's your 0, and we carry this 1, so that gets carried here. So our next sum is 1 plus 1 plus 1. Now let's just write that down here, 1 plus 1 plus 1, which is 3. But again, we don't have access to this 3 symbol, so we need to express it in a binary 3, which is 1, 1. So we write down what's in the right hand column, 1, and we carry what's in the left column. So 1 plus 1 again, which we know is a 3, so 1, 1. 1 plus 1 plus 0, which is 2, and we know that a 2 is expressed as 1, 0. So we write down the 0 and we carry the 1. Nothing left, so we put the 1 down. Now, so 1, 1, 1, 1 plus 0, 1, 1, 1 is 1, 0, 1, 1, 0, base 2. We need to check this, and because binary is very difficult for us to work with because we've not been using it since childhood, we need to convert it into its decimal equivalent. So to do this, don't make life difficult for yourself, just use the placeholder grid that you're used to. So let me get my red pen, let's put in the placeholder grid. So we've got 2 to the power 0 is the first column, 2 to the power 1 is the second column, 2 to the power 2, 2 to the power 3 and 2 to the power 4, just what you're used to. Now what do these represent? So 2 to the power 0 is the 1's column, 2 to the power 1 is the 2's column, 2 to the power 2 is the 4's column, 2 to the power 3 is the 8's column, and 2 to the power 4 is the 16's column. So we've got 1 in the 16's, so that means we are saying 16 plus, we've got nothing in the 8's, we've got 1 in the 4, and we've got 1 in the 2. So 16 plus 4 plus 2 equals 22. So we have just checked and we know that this is correct. 15 plus 7 does indeed equal 22.